Here I am in the wilds of Montana, thanks to the wonders of technology. And I'm going to walk you through a little bit of a tour of the Dinosaur Hall for those of you who haven't been there, haven't seen it. Give you a little bit of a background about why we have a hall, how it came to be, and a little bit about the fossils that are exhibited. So why do we have dinosaurs, number one? The title was Cincinnati dinosaurs, and there aren't any, of course, in our area to be found because the rocks are of the wrong environmental type and wrong age. But a natural history museum has to have dinosaurs just like a zoo has to have lions and tigers. Also, they are a fantastic gateway drug to science, as I like to say. They're great ambassadors for the STEM field, get people excited about science and technology. So most big museums have a dinosaur hall. So what is a dinosaur exactly? Most of us think we know one when we see one, but frankly, there are really only two characteristics that make a dinosaur, and it has to have these characteristics in order to be that. So what we see here are three different types of reptilian skulls, and they're defined by the types of openings they have in the back of the skull, essentially to allow for muscle expansion. Anapsid condition has no openings, the synapsid condition has one on the side, and the diapsid condition has these two openings. Dinosaurs have to have a diapsid skull. They come from that lineage that includes crocodilians and pterosaurs and snakes and lizards, diapsid reptiles. The synapsid group is the thing that contains us, animals that evolved into mammals ultimately. The other thing that a dinosaur needs to have is an erect gait. And what I mean by that is they have to have a posture in which their limbs are held directly below the body. That's not just a bipedal stance. Quadrupedal animals like the Triceratops here also hold their limbs directly below their bodies. That's something we see in mammals, of course, but mammals, remember, have that synapsid skull condition. Crocodilians are diapsids. Lizards are diapsids, but they have a sprawling gait where the limbs are held out to the side of the body, essentially. So that's the big difference. If you got those two things, you have to be a dinosaur and nothing else. If we look at modern tetrapods, we can sort of see a relationship of how these organisms are related to one and another evolutionarily. The synapsid and diapsid diversion is right here, right? So synapsids leading to mammals share a common ancestor with these diapsid groups. Up at the top, there's a thing called Archaeopteryx that unites crocodilians and dinosaurs, which modern birds are, and we'll say more about that in a little bit. Looking at the evolutionary relationships of dinosaurs, that same sort of relationships where organisms have they share a common ancestor along these evolutionary branches. The two big groups of dinosaurs, as they're typically understood, are the Saurischia here and the Ornithischia here. And those are determined by their hip structure. So Saurischian dinosaurs, lizard or reptile hip dinosaurs, include things like the big theropod carnivorous dinosaurs. The Ornithischians, bird hip dinosaurs, things like Stegosaurus and Triceratops and animals like that. It's an interesting historical artifact that Saurischian dinosaurs, the so-called lizard hip dinosaurs, are the group that gave rise to modern birds, whereas Ornithischians really have nothing to do with them. It's only that they sort of superficially have a bird-like hip, and that was recognized in the 19th century when these categories were coined. A larger phylogeny of Dinosauria shows you that there are many, many different groups, again, splitting the Saurischians from the Ornithischians. And in our dinosaur hall, we have pretty much exclusively Saurischian dinosaurs, a couple of small exceptions. So things like the Tarbosauridae here, Allosauroidea, Tyrannosauroidea, and then we have some sauropods, primarily in the diplodocid group. And here is our dinosaur, this hall. This is what you see when you enter the museum. Again, primarily Saurischian dinosaurs. That was not necessarily an active choice. It's just that you work with what you've got, really. And what we did want to do is that make sure that the bulk of the fossils that we are showing are original dinosaur skeletons, things that can inspire awe and excite the public. You know, art museums don't apologize for putting the real things on exhibit. We want to put real dinosaurs on exhibit. So how did we get these dinosaurs? They are primarily Jurassic in age, and that is because we decided we were going to go out and look for some, and one of the better places to do that was in rocks of the Morrison Formation out in the American West, some of which you can see behind me. Morrison Formation is late Jurassic in age, and it produced the first complete or essentially complete dinosaur skeletons in the world. Things like Brontosaurus up here, at the time now Apatosaurus at the American Museum, Diplodocus at the Carnegie Museum in Pittsburgh and the British Museum in London. And Morrison dinosaurs are so famous that, of course, there's even a series of stamps that have been produced. So the Morrison Formation has originated some of these very, very famous late Jurassic dinosaurs. The ones I mentioned, Stegosaurus, Brachiosaurus here, Allosaurus. So it seemed like a good place to go. And indeed, we did find a good site out in Montana at the northernmost range of the Morrison Formation. Now, Montana looks a lot different today than it did in the past. A very, very different ecosystem. And one of the things that we wanted to do in the Dinosaur Hall, and we had an opportunity to showcase, were fossils beyond just dinosaurs, the sorts of things, plants and invertebrates and smaller reptiles and even a small mammal that would have been associated with the dinosaur skeletons that we have on exhibit. So we went out to the Morrison Formation, went out to Montana, and spent a decade or so collecting dinosaur specimens for research and exhibit. And in particular, we spent most of that time at a place called the Mother's Day site in near Bridger, Montana. It's called the Mother's Day site because some volunteer for the Museum of the Rockies discovered it on Mother's Day. I was never allowed to go out and look for fossils on Mother's Day, but nevertheless, that's the name of the site. And it produced many, many fossils over the course of the years, and it's still producing. The Morrison Formation itself is a group of terrestrial rocks that represent floodplains and rivers and ponds and lakes. And that's what you get here in these colored rocks. Around Cincinnati, our rocks, my colleagues may disagree, but they're a lot more monotonous. They're all gray in color. They have great lateral extent. That's because they're laid down at the bottom of a very stable, relatively stable ocean. But in terrestrial settings where you have meandering river systems, the environmental types change and then the different rocks are deposited. So this big buff sandstone represents part of a river channel. These different colors here are floodplains with different oxidation states of the minerals within them that reflect different degrees of moisture, high or low water tables, that sort of thing. So we're able to look at those rocks and interpret the environment. And very briefly, it was a very, very big depositional basin stretching essentially from Oklahoma up into Montana. We know that the climate was monsoonal, alternating aridity and periods of rain. There were big rivers in it. Along these rivers, there were large forests with a lot of resources for animals that would eat vegetation. And then those rivers were separated by large stretches of plains that may have been quite dry and not a lot of resources for these animals. Water would dry up periodically because of the seasonal aridity. And as a result, big herbivores dominated this environment because they were able to migrate from the resource-rich areas across the resource-poor areas to new areas of resource once they had used that original source up. And large animals are better able to tolerate those sort of conditions. So if we looked at the world today, analogs might be something like the Amazon basin in size, because this was a great big area across the Western US. The New Guinea might be a good place you would look for tropical rivers versus the savannas in Namibia. Now, bear in mind that the plants are very different, but these are the sorts of environments, the sorts of topographies that you might run across in the Morrison. And there were animals migrating across these regions. And to make a long story short, at the Mother's Day site, we have an accumulation of a herd of dinosaurs migrating across one of these relatively arid plains and coming across ephemeral water bodies, ultimately the water drying up and the animals died of drought and then were deposited at this site. So as a result, we have collected thousands of dinosaur bones of one particular species, which we've identified as Diplodocus from the Mother's Day site. An example here, of course, a nicely preserved bone. Some excitingly, patches of dinosaur skin as the carcasses sort of mummified, dried out because of the arid conditions before they were ultimately buried. And we have collected the smallest known example of a Diplodocus skull, and represents a juvenile animal. And you can see this skull in the museum, along with a composite skeleton of this juvenile Diplodocus here. Sauropod dinosaurs, to which Diplodocus belong, are these giant dominant herbivores of the late Jurassic. Now, next to Diplodocus is maybe a more exciting dinosaur here on exhibit and here in the ground out in Montana, about 20 miles away from the Mother's Day site. This is an animal called Galliumopus. And Galliumopus is a relatively rare sauropod dinosaur, or at least it's only been recognized as a new taxon in 2015. There are probably only 3 skeletons that have currently been identified as Galliumopus. Maybe there are more out there in museum collections, but amongst the 3 that have been recognized, ours is likely the best example. We have also in the museum created some nice bronze touchable exhibits. So here's a restoration of what Galliumopus's head and neck may have looked like, and that's available to the public. I mentioned that the Morrison is famous for the dominance of giant sauropod dinosaurs, these big herbivores. It also has quite a diversity of sauropods within it. Apparently there was some degree of niche partitioning going on, different animals eating different sorts of plants. And we have over in the corner our little Diplodocus skull here. We have a Camarasaurus skull, which is kind of a different family of sauropods. It's called a macronarian, but anyway, different shaped teeth, different diets presumably. And here as well, the skull of Apatosaurus. And Apatosaurus is a very, very famous dinosaur, but to be honest, there are only 3 or 4 skulls known of the animal. Ours is the best one in existence. It's the only one that was ever discovered connected to the neck of the animal, therefore confirming what the postcrania actually looked like in Apatosaurus. So it's a very exciting research specimen, as is the baby Diplodocus skull. And in fact, virtually all of the skeletons and fossils in our exhibit, we've gone out of our way to try to make sure that material that we exhibit was of high research quality as well as exhibit quality. So there are quite a number of sauropod skulls here, bits of other pieces, bits of Galliumopus and things. So right there we have 4 different types of sauropod skulls. We have part of a 5th Barosaurus in our collection. It turns out that we probably have the 2nd best collection of sauropod dinosaur skulls in the world, second only to the Carnegie Museum, maybe with the Smithsonian a close 3rd. Okay, moving away from the sauropods, here, left-hand corner, we see these big herbivorous dinosaurs, and trailing along behind, we have a nice little cast of the only ornithischian dinosaur we have in exhibit. Neelasaurus was a small herbivorous dinosaur. I won't say much about it, other than that it represents some more of the diversity of the Morrison Formation. This is a cast, but it was donated to us by a good friend of the museum who continues to collect fossils out in Utah, and helped us with the exhibit in many ways. All right, so if you have big herbivores in your environment, you're gonna have big carnivores as well. And here are the two very exciting skeletons. One is Allosaurus, the other is Tarbosaurus. Allosaurus is certainly the most famous and most common carnivorous dinosaur or theropod from the Jurassic, from the Morrison Formation. It's known from dozens of skeletons. This particular individual is a composite made up of a number of individuals, likely from a bone bed out in Utah, where 45, 50 plus individuals died in one site. It's not entirely clear why that is, but a very famous site, very famous dinosaur because it's so well represented and so well understood. Along with the Galliumopus reconstruction bronze bust I showed you, we have bronze restorations of the skeletons of all the dinosaurs that are represented in the exhibit. So these are touchable. You can, for the visually impaired in particular, you can experience the skeleton on one side, and the other side, the fleshed out restoration of what the animal may have looked like in life. And we have a shadow herd, which is kind of a unique thing. I don't have a movie of that to show you, I'm afraid, but periodically along the wall of the exhibit, the sauropods in silhouette are being chased by a big carnivorous dinosaur. Now, although it appears in this image to represent Allosaurus, if you look closely, it's got a longer, narrower snout, and it is in fact the other big theropod that we had there, Tarbosaurus. And this is a very exciting skeleton, very exciting research specimen, because this is the only associated Tarbosaurus skeleton in the world. This is the apex predator, we believe, for the late Jurassic, much bigger than most Allosaurus specimens. Not very well known, only described in the 1970s from isolated or semi-associated bones. And here we have more than half of a skeleton that was found together, essentially, more or less articulated and associated. And there are still additional bones of this skeleton coming to light, which are coming to the museum. Tarbosaurus is very exciting, as I say, because it's so poorly known. This is an important research specimen. There are bones in this skeleton that have not been seen before for this animal. So we're learning more about the anatomy of this dinosaur. And Tarbosaurus, interestingly, is one of the few, if not the only, megalosaurid dinosaurs in North America. And Megalosaurus, shown below, is the first dinosaur described to science, so the first dinosaur named in England in 1824. And our understanding of these dinosaurs have progressed quite a bit since the restoration down in the lower left-hand corner here. These animals would be more like this up here. But it's a very interesting connection with Europe and the history of dinosaurs, and as I say, an important research specimen. I had Jurassic Park at the Mother's Day site indicated earlier. This is really exciting, I think. This is the spot here in the Morrison Formation where the Tarbosaurus came, just right in this area it was discovered, and that's in the town of Dinosaur, Colorado, right next to Dinosaur National Monument. Again, couldn't get a better site to find a big, important dinosaur skeleton. Now here, these hills in the back actually are part of Dinosaur National Monument. Trying to hurry along here. Moving up to the Cretaceous, we do have a few Cretaceous dinosaurs, and this one in particular, Dinosaurus, is another very exciting fossil. It is a Tyrannosaur, not quite as big as Tyrannosaurus rex, and somewhat older. It's about 10 million years older than Tyrannosaurus, so it's best to think of it as a close cousin maybe of Tyrannosaurus, if not directly ancestral. It's a very advanced theropod dinosaur. Tyrannosaurus is maybe a dime a dozen these days. Dinosaurus is not very common at all, so it's great to have a skeleton that's 80% complete or so. It's really a fantastic beast. Below the skeleton of Dinosaurus, we have a couple of casts of Dromaeosaurus, which is similar to a velociraptor from the films. A small, agile, active animal. And in this restoration, there's something unusual about it relative to the other dinosaurs we've been seeing, and that it is feathered. It is a close relative to modern birds, which I mentioned earlier are living dinosaurs. How can that be? Are birds birds, or are they dinosaurs? Well, it turns out that they are both. Birds are a subset of the larger group Dinosauria, and they are indeed living dinosaurs being directly descended from small theropod or carnivorous dinosaurs. I mentioned their diapsid skull of dinosaurs. Birds have this condition. They certainly have the erect gait. But I think the most obvious thing, just look at a bird, like a chicken foot down here, is that it is very, very similar to the traditional non-avian theropod dinosaurs like Tyrannosaurus. Now, this is not to say that birds evolved from Tyrannosaurus or dinosaurs like that, but they did evolve from a common ancestor ultimately. If we look at what was considered the first bird in the past, Archaeopteryx, there are lots of features here that are becoming very bird-like. The hip is becoming much more like modern birds, although it is this saurischian pelvis that we talked about earlier. It's got long, long forelimbs, but it retains many, and it of course has feathers, which are preserved in the lithographic limestone where these animals are found in Germany. But it retains a lot of reptilian features too, like the long tail, teeth in the skull, fingers on the wings. So today it's considered a Paravian dinosaur, not quite a bird, but definitely on that way to becoming a bird. So if we look at theropod dinosaur evolutionary tree, Archaeopteryx around here, we have our modern birds up here, and at each of these points, organisms share a common ancestor. So tyrannosaurs have branched off more early. Dromaeosaurs like Deinonychus, Velociraptor, Dromaeosaurus, much more close to birds. You see Allosaurus is a more primitive dinosaur than the Tyrannosaurs. Our Tarbosaurus would branch off somewhere down here. So that's dinosaur phylogeny in a nutshell. Other things that I can encourage you to do once the museum is open again for business, explore the gallery. Not only do we have these great skeletons to look at, we have a number of interactives, things such as viewing scopes that allow you to see specific points on the skeletons, replicas of dinosaur footprints to explore and engage with. You can measure yourself up against Apatosaurus, or play with our interactive globe, which allows you to travel through time and see where Cincinnati was on the planet and what the position of the continents were at the time. And lastly, see our Paleontology Lab. We have an active laboratory off the dinosaur gallery where dinosaurs and other fossils are prepared in front of the public. They're big glass windows, and you can see staff inside working on things such as this Triceratops skull here. So please do visit the dinosaur if you have the opportunity. And I want to thank you all for attending today. Remember that we're a nonprofit institution, and being closed to the public the way that we are, we do rely on our ticket sales and our membership. So please renew your membership, or join if you're not a member, or perhaps donate to our COVID-19 closure fund. And you can see these opportunities and other social media opportunities and programming on our website at cincymuseum.org. So thank you very much. And if there are any questions, I'll try to get to that. Let me see what I do about there. So I'll leave it there. Let's see.
Hey, Glenn, have any mammalian remains been found at the Mother's Day site?
Not at the Mother's Day site.
Or nearby, I suppose?
Well, in the Morrison Formation, certainly. We have another site that we've worked on in Utah in partnership with Marietta College and Northern Kentucky University. And that has produced a mammal jaw, thing called Creachodon, which is on exhibit currently in the Dinosaur Hall. So mammals were around, certainly. And in fact, the first 2/3 of mammalian history overlapped with the age of reptiles, so-called. Dinosaurs are still with us today, of course, but during the Mesozoic, there were lots of little small mammals around underneath the feet of these dinosaurs. Down in Wyoming, a place called Como Bluff, there's a very important site called Quarry 9 that was discovered in the 19th century, and it's produced 200 or more Jurassic mammals. But nevertheless, they still remain quite rare. And so it was exciting to get one through our partnership with Marietta and NKU.
So considering what appears to be quite a bit of environmental diversity, we have just a very, very small snapshot of the actual fauna that's there. Flora, from the same perspective, I would think would be very similar, where we don't have a whole lot of information beyond maybe some of the big coniferous trees. What about fish and things like that? Or do we have any evidence of amphibians or fish with some of these water environments?
Oh, absolutely, we do. In fact, we have a very good snapshot of the Morrison environment in general. So you asked specifically about the Mother's Day site. Really, there we just have this monospecific assemblage, this herd of dinosaurs that died in isolation, essentially. There are some macerated plant remains of conifers associated with them, and a few Allosaurus teeth that may have scavenged on the remains. The only other thing we ever found at the Mother's Day site was a concostracan, or actually two of them now, which is a shelled crustacean, freshwater crustacean. That was about it. So not much to find at the Mother's Day site other than Diplodocus. However, throughout the Morrison, we've talked about mammals. There are lots and lots of different kinds of plants. There are lots of invertebrates like clams and the concostracans and other things. There are a variety of fish as well. Bony fish, lungfish. In fact, there's a nice lungfish tooth or tooth plate on exhibit at the museum. We have crocodilians and turtles, frogs, as you mentioned, from the Morrison. Now, granted, many of these things are rare because they're small and delicate and hard to preserve and hard to find. So frog bones you don't turn up every day. One thing that we also have from the so-called Aaron Scott site in Utah that we're working with Marietta and NKU on is a humerus or upper arm bone of an animal that's a dead ringer for Archaeopteryx. So we think we do have a paravian in that site, if not Archaeopteryx itself, something very, very similar. And that's exciting because Archaeopteryx is one of the most famous of fossils, and to have a piece of something at least very similar in our collections is kind of cool. Anything else, anyone?
What do the plans look like for our Dino Hall with the SVP conference coming up? And I guess where does that stand? Yeah,
so the Dinosaur Hall would be really the centerpiece of our opening or welcoming reception for what was anticipated to be 1,500 paleontologists from around the world. It's not entirely clear who will be attending if the meeting even goes forward. I've had some discussion with executive committee and other officers in the Society of Vertebrate Paleontology, and we're looking at contingencies. One would be to have the meeting as usual, depending on travel restrictions and social distancing and that type of thing, what that would allow. Another alternative might be to have a virtual meeting where papers are presented through video conferencing similar to this. And a third alternative might be a hybrid of the two. People who felt comfortable coming to the meeting could be here in person, and presentations be live streamed. Others present virtually, remotely. So we'll just have to see, fingers crossed, how that goes. It was a very exciting opportunity for us to have the Society of Vertebrate Paleontology come to Cincinnati because it's the premier organization for people who study dinosaurs and other fossil vertebrates. It's a recognition that Cincinnati is an important program in paleontology. Not only VP, but IP has a long tradition of study, research, education, and collecting in paleontology. So we'll see where that goes. I would like to have my colleagues see the Dinosaur Hall, of course, and the museum in general in October.